Hi, welcome to this first session on SAP Warehouse Management. In this session, I will be presenting an overview on SAP Warehouse Management, its advantages over SAP IM. I will be discussing the org structure of SAP WM and also the various WM terms and documents that you would typically see in SAP WM module. I will also be discussing the interface with other modules. So, with this session, you will be getting a preliminary idea of SAP Warehouse Management without getting much into the customizing details. We start with an overview of SAP Warehouse Management. So before we get into the details, a brief history of SAP Warehouse Management. The Warehouse Management solution was introduced in the R2 version of SAP itself. As of SAP R3 4.5 version, the warehouse management part along with the shipping and transportation were brought together to form the logistics execution module as a whole. The warehouse management application is fully integrated into the SAP R3 system. The transactions that are initiated in other SAP components result in corresponding tasks in WM, which activate the actual physical transfer within the warehouse. So for example, if a goods receipt is posted in inventory management system, the stock level is increased in the WM system. Because of the goods receipt posting, an action is started in the WM system that notifies the user that material must be stored in the warehouse. So this means that the WM module is very tightly integrated with the IM module and also with other modules. So any change that is seen in the IM module or any other module will also be reflected in the WM module in real time. So what are the advantages of SAP Warehouse Management? So before we actually talk or discuss the advantages, let us first try and understand the fundamental question, why warehouse management? So while inventory management as part of the materials management can only provide information on the total quantity of material in stock, warehouse management enables a precise specification of the exact location of a particular quantity of material and informs you whether this quantity is currently in a storage bin or on the move. This means that the most fundamental advantage of having SAP Warehouse Management implemented is that it allows you to have a visibility of the available stocks at a bin level. You can, in real time, see whether the stock is available, whether it is being put away, whether it is being picked, and this kind of visibility gives the warehouse manager or the management ability to make informed decisions. Now we see some of the other advantages of SAP WM. This is only a partial list. There are many more advantages. The first and the most important advantage that SAP WM is seamlessly integrated with other modules like PP, QM, SD and MM. So any change that is initiated in these modules has an implication in real time in WM as well. SAP WM offers you the functionality to use RF scanning. The RF scanner is used to scan something called as a barcode label. Now this label has the entire information about the material and is pasted on the package. Once scanned, all the information is transferred into the system. The operator does not need to read or count any material. This reduces the human error. Since SAP WM is integrated with IM, you have a good inventory visibility and a real-time inventory and end-to-end visibility and tracking data. So you can make out whether the material is in stock, or it is coming in, or it is being picked or being moved within the warehouse. So you can have a complete tracking of what has happened to a material or what is happening to a material. Reduced inventory loss. Because the material is now managed at a bin level, you can actually keep a track of the inventory at a bin level. And because you are keeping a track of the stock at a bin level, you have better control on the inventory. And this results in reduced inventory losses. Improved operational efficiency. Now, an SAP warehouse management provides you functionality like a warehouse activity monitor or an RF monitor or a yard monitor. Now, what these monitors do is that they enable the warehouse supervisor to actually have a bird's eye view of what are the activities that are happening in the warehouse. So for example, if there are any transfer order pending, if there are any deliveries to be picked, or if a particular operator has a tremendous workload, he can transfer some of the workloads to another operator. So operational efficiency in a warehouse is improved. Improved transactions between receiving and put away. We have a functionality of cross-docking which allows to match outbound transfer orders for a material with incoming transfer orders. This means that if you have a delivery for a material pending and you also have an incoming receipt of this material, then you can match the transfer orders and avoid unnecessary put away of the material into the warehouse. So once you receive the material in the goods receiving area, it is directly assigned to the outbound transfer order. Business transparency and informed decision making. Since WM is integrated with other modules, all the stock, all the data that you see in the WM is real time. So this leads to transparency and you can make informed decisions. Let us now discuss the WM structure in SAP. We will first have a look at a structure without a warehouse management system in place. So this is case 1. So if you are not using the warehouse management system, the storage location is the lowest level of inventory management in the system. So you can see one plant linked to a single storage location or a multiple storage location, and that's it. If you are using inventory management without WMS, you can assign one or several physical storage locations to each plant. Let us see a case wherein WM comes into picture. So when we have WMS in the picture, we can see that the warehouse management starts where the IM stops or ends, meaning the warehouse is linked below a storage location. So a plant is connected to a warehouse via a storage location. So what you see on the screen is a plant, a storage location, and a warehouse. The warehouse has storage types which we will see in subsequent slides. There is another case which we can see that two plants are linked to one warehouse, which is possible in SAP. So you have a huge warehouse which is sharing space for two plants. So two plants are stocking material in one warehouse. So can we have two warehouse management systems in a given plant? Yes, you can. What this means is that one plant having two warehouses. Yes, this is possible, Of course, you will have to have individual storage locations pointing to each warehouse. So you have to have a unique plant storage location and a warehouse combination. Can we have a WM cutting across two plants? Yes, you can have. As a rule, it is a good idea to maintain only the stocks of one storage location and the same plant within a warehouse. But yes, if there is a pressing business need that a warehouse wants to share space for two plants, you can do that. You can manage several storage locations of one and the same plant within a warehouse, or two plants within a warehouse. It is possible. Does a warehouse have accounting implication? No. Warehouse is purely stock handling. All the accounting implications are at an IM level. Does all the storage type necessarily be located in one building? No. They can be scattered. For example, you have one building stocking a particular material and another building across the road which has another material or kind of same material. So do you need to actually build two warehouses in SAP system? No, you can actually have one warehouse and call those two buildings as two different storage types, which is possible. Let us now have a look at the warehouse hierarchy. So at the top we have the warehouse number, then we have something called the storage type. Below the storage type we have something called the storage section or the picking area. Below the storage section we have something called the storage bin, and finally we have the quant. If your warehouse is storage unit managed, then the storage unit would come just below the storage bin and above the quant in a warehouse hierarchy. This is just for information. So we will discuss each of these organizational units in detail. Let's start with the warehouse number. The warehouse number is the superordinate organizational unit in warehouse management in SAP R3. Superordinate means highest in rank. It is used to represent the physical warehouse complex. Each warehouse number has a substructure that maps a spatial relationship in the warehouse complex in detail. So you define a warehouse complex with an alphanumeric 3-digit key in SAP, which is linked to a storage location and a plant. So what is a storage type? So within your warehouse, you have to define the spatial arrangement of how you are stocking material. So you may be keeping one type of material at one place, a particular type of material at a different place, and you will want to be able to segregate these materials. So you can use something called as a storage type. So storage type is a physical or a logical subdivision of a warehouse complex that is characterized by its warehouse technique, the space used, its organizational form, or its function. So a specific storage type is the most fundamental design element in the warehouse. You define the picking and the put away strategy at a storage type level, and that is why everything that is kept in that particular storage type has the same picking or the put away strategy. So if you have a material that you would want to pick as per first in first out strategy, then you would keep all that material in one particular storage type. So that is a reason that storage type is at the highest level in hierarchy. A storage type has following features. A storage type does not have an address but a short description. You could have a description like pick face or a high rack. This description helps you to identify what kind of storage type it is, what are the characteristics that the material stored in this storage type might be having, and how the material may be being put away or being picked, something like that. It is possible to maintain storage type specific material data. So if you want a particular material to be stored in a particular storage type, you can specify that in the material master. So for example, fixed bins. If a particular material needs to be put away in one specific bin in a particular storage type, then you can extend that material to that storage type and specify the bin in the WM2 view. Strategies for put away and picking are maintained at storage type level. Let us now see the other org structure units. The storage section. The storage section is an organizational subdivision of a storage type that groups together storage bins with similar features for the purpose of putting away stock. The criteria for grouping bins, for example, could be heavy parts, bulky material, fast-moving items, slow-moving items, etc. So, in a particular storage type, if you want to again subdivide this spatial arrangement and would want to group together materials that you have put in a group of bins which would have, say, common characteristics, then you can subdivide a storage type into storage sections. So a material that is coming into the warehouse could always go into that particular section of the storage type, and it could be picked from that particular section. So a common subdivision is heavy parts, bulky material, or fast moving items. So in a particular storage type, if you are having heavy parts and also the lighter parts, then you could subdivide your storage type as heavy parts at the bottom, and at the top you keep the lighter parts. So whenever the heavy parts come into the warehouse, they are going to be stocked always at the lower section of the storage type. You can manage this or design this in the search strategy. Picking area is a section within a storage type in which all picking activities are carried out in the same way. Now, picking area is another subdivision within a storage section where you can define this area as a picking area in which all the picking activities would be carried out in the same way. Picking area is optional to define. Storage section is mandatory to define. So you may not want to have elaborate subdivision of a storage type, but SAP needs minimum one storage section per storage type. So you have to have at least one storage section for a storage type, and having a picking area is optional. Next, we have the storage bin. A storage bin is the smallest addressable unit of space in a warehouse. Storage bin type is used to subdivide into groups, for example, large bins, small bins, etc. So, storage bin is for stocking your material. Now, the storage bins could further be subdivided using an element called storage bin type. So if you have segregation of bins like large bins, small bins, then you can define a bin type as large bins, as small bins, and you can assign this particular bin type to the storage unit type that you will have to define. So with these linkages, you can make sure that the material, when it comes into your warehouse, would automatically find the specific bin type to which it should go and it should be stored. So you can plan and design to that granularity. Quant. A quant is the stock of any material with the same features in one storage bin. Quants can be created or deleted solely through goods movement. So whenever you post a goods receipt at an IM level, at a WM level, a quant is generated. Now this quant is a numeric identification for that stock of material, and it would be there till the material is in the warehouse. Once it leaves the warehouse, the quant number is automatically deleted. So what is the criteria for generation of quant or for quant splitting? So if you have doing a goods receipt and you have two material number in the same goods receipt, then two quants would be generated. Similarly, if plant and storage location is different, two quants would be generated. The stock category of the materials are different, quant would be split. It would be split if the material have different stock, special stock assignments or different batch numbers. All these factors would make the quant to split. Let us quickly understand an important org element called the interim storage type. An interim storage type actually acts as an intermediate between IM and WM. The inventory management application component communicates with the warehouse management component through interim storage types. Goods receipts and issues are posted in IM are automatically updated in WM in these interim storage type. So interim storage type actually forms a link between IM and WM. So whenever a posting is done in IM, the connected posting happens in the interim storage type first, and from there it moves ahead into the WM. Similarly, whenever a posting or a change happens at a WM level, it is first going to the interim storage type and then it is reflected at an IM level. So for example, you are doing a goods receipt for a purchase order from a vendor. The moment you do a MIGO, the stock goes into an interim storage type 902. From 902, this has to be further put away into the bin. Till the time you don't put away the stock using the transfer order, it lies in 902, which is also the goods receipts area. Similarly, whenever you are doing picking for a delivery, you pick from the warehouse, the stock goes from the bin into the interim storage area 916. So when it goes to 916, the status of the delivery shows picked. Further, if you do a goods issue, the status of the delivery is goods movement completed and the stock has moved out of the warehouse. So we have many other interim storage types used for those specific purposes. What you see on the screen is only a partial list of the important interim storage types. So after understanding the org structure hierarchy, let us understand what from this org structure is customizing and what is master data. So the warehouse number, storage type, storage section is a customizing part, and whereas the storage bin is the master data. Along with storage bin, you also have to change the material master and add WM views to it to fully complete the WM integration.